Hi, hello dear students. Welcome to physics class of PU2. In the previous video classes, we have explained about the chapter atoms and we have completed it. Now, in this video class, I am going to start here the next chapter, chapter number 13 from the part 2 book, that is the nuclei. In the chapter atoms, we have explained different atomic models proposed to explain the structure of an atom. J.J. Thomson atomic model, Rutherford atomic model is also called as Rutherford nuclear atomic model because Rutherford discovered the nucleus from his famous alpha particle scattering experiment. And also we have discussed about the Bose atomic theory, Bose model of an atom, its merits and demerits, that is the limitations. So with all these points, we have to start here the next chapter, that is the nuclei. So from the Rutherford alpha particle scattering experiment, from its experimental observations and conclusion, we know that the almost all mass of the atom is concentrated at the central core of an atom, that is called as what? The nucleus. Right? The whole mass and the whole positive charge of the atom is concentrated at the center of the nucleus, at the center of the atom, that is called as what? The nucleus. Right? So the nucleus consists of what then? The nucleus consists of what? The protons and neutrons. The nucleus consists of what? The positive charge of the nucleus is mainly due to what? The protons. Because the elementary particles, subatomic particles, these electrons, protons and neutrons, right? These are called as what? The subatomic particles. These protons are positively charged particles and neutrons are electrically neutral. Neutrons are electrically neutral. They doesn't have any charge. Right? The charge of the positive charge of the nucleus, it is due to what? The protons. And these protons and neutrons combinedly called as what? The nucleons. The protons and neutrons combinedly called as what? The nucleons. Right? The protons and the neutrons combinedly are commonly called as what? The nucleons. And also you know that the electrons, the negatively charged electrons are revolving around the nucleus in various orbits. And the charge of the electrons is negative. So electrons are negatively charged particles. So electrons are what? Negatively charged particles. So we have protons, neutrons and electrons. These are the subatomic particles, right? Neutrons and protons, they present inside the nucleus. They combinedly called as what? The nucleons. Protons, which are having the positive charge, right? The electrons, which are revolving around the nucleus in various orbits and which are having the negatively charged particles. What is the magnitude of the charge of the proton? What is the magnitude of charge of the electron? The magnitude of charge of the proton is 1.6 into 10 to the power minus 19 coulomb. It is plus. So the magnitude of charge of proton, which is equal in magnitude as that of the electron, but it is positive. For electron it is negative. Right? So this is the basic point related to what? The nucleus, which consists of what? The nucleus consists of what? Protons and neutrons. These combinedly called as what? The nucleons. The electrons are negatively charged particles which are revolving around the nucleus in various orbits. And one more important point related to their charges and the magnitude of charges. And the next point related to the properties of the nucleus, also we have to discuss here. The properties of the nucleus, which is the subject matter of the study of the nucleus and the nuclear physics. right? What are the important properties of the nucleus also we have to study here. Now the composition of the nucleus, let us study here. Composition of the nucleus. The composition of the nucleus. So how you are going to represent here the nucleus of an atom. The nucleus of an atom is represented by what? The symbol XZA, right? The nucleus of an atom is represented by the symbol XZA. What is Z here and what is A? Z represents what? Atomic number. Z represents what? Atomic number. And A represents what? Atomic mass number. Z represents atomic number and A represents what here? Atomic mass number, and X represents what? It is an element. Which represents what? For example, you know that the atomic number of an oxygen atom is 8, right? And its atomic mass number is 16. Atomic mass number of oxygen is 16 and its atomic number is 8. So what does it mean? So the 8, which represents what? The number of protons present inside the nucleus, which represents what? The atomic number. And this 16 represents what? The atomic mass number, which is equal to the sum of protons and neutrons present inside the nucleus. So this 16 is equal to what? It is the atomic mass number, right? So here A is equal to what? Number of neutrons plus number of protons. So N plus Z. As Z represents what here? The number of protons, that is equal to the atomic number. And N represents what here? The number of neutrons present inside the nucleus. So this 16 is equal to what? The number of neutrons and number of protons. Then how you are going to find the number of neutrons present inside the nucleus? So then N is equal to what? A minus Z, which gives the number of neutrons. So how we are going to find the number of neutrons present inside the nucleus? A minus Z. So A minus Z gives the number of neutrons, right? So this is the composition of the nucleus. Generally it is represented by the symbol XZA. For example, oxygen, right? 8, 16. 8 is the atomic number. Z is atomic mass number, which is the atomic mass number. But atomic mass number is equal to what? A is equal to N plus Z. That is the number of sum of number of neutrons and protons. Then how you are going to find the number of neutrons? N is equal to A minus Z. Now coming to the representation of masses of these protons, neutrons and electrons. So these are the very light particles. The masses are very small, and in those cases in nuclear physics and atomic physics, these masses are represented in AM, right? Atomic mass unit, or it is also called as what? Unified atomic mass unit, right? AMU, atomic mass unit. What is atomic mass unit? It is the 1/12 of the mass of carbon 12 isotope, right? 1 AMU. 1 AMU is what? It is the 1/12 of the mass of C612 isotope. Now we are going to define here what are isotopes, what are isobars, and what are isotones related to the properties of the nucleus. Before going to that, let us see here the conversion of the masses. That is the mass of the proton, who we are going to represent it in terms of AMU. That is how we are going to represent it in terms of kg. 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. So this is the relation between AMU and kg. So here in this table I have given here the particle, their masses in kg and their masses in AMU, right? So proton, its mass in kg is 1.672 into 10 to the power minus 27. But in terms of AMU, it becomes 1.00727. Based on this conversion formula, that is 1 AMU is equal to 1.66 into 10 to the power minus 27 kg. With this relation, we have to convert it. Next, the neutron, which is electrically neutral. Know this: proton is positively charged particle and electron is negatively charged particle. And the mass of the neutron in terms of kg is 1.675 into 10 to the power minus 27. Now in terms of AMU, 1.00866. Again, for an electron, mass in kg is 9.1 into 10 to the power minus 31, and which is in terms of AMU is 0.00055. So which is less than the mass of the electron, which is less than that of the proton and neutron. Right? Electron is more light as compared to that of the proton and neutron, and proton and neutron, mass of the proton is nearly equal to that of the mass of the neutron. Right? So with this table is very important to solve the numericals. So while solving the numericals based on this chapter, we are going to use these masses in terms of AMU. Right? This is about the masses. Now the next point related to this, we are going to discuss here the properties of the nucleus. Properties of the nucleus. So in properties of the nucleus, let us discuss here what are isotopes, what are isobars, and what are isotones. So these are the three important definitions we have to see here related to the properties of the nucleus. Then we will discuss about the nuclear charge, nuclear mass, and nuclear density, how we are going to represent it. Now what are isotopes? Right? What are isotopes? Isotopes means what? The nuclei with the same atomic number but different mass number. Those are called as what? The isotopes. What are isotopes? Nuclei with same charge but different age. These are called as what? The isotopes. What are isotopes? The nuclei with same atomic number but different mass number are called as what? The isotopes. Nuclei with same atomic number but different atomic mass number are called as what? The isotopes. Here we can give the examples, right? 1H1, it is all these 1H1, 1H2, 1H3, all these are the isotopes of hydrogen. Again, C610, C612, C614. So here in these examples you can see the atomic number is same but which are having the different mass numbers. Again, carbon, if you are observing here, right? C610, C612, C614, the different mass number but same atomic number. Again, one more example I can give you: uranium 92-235. It is the radioactive element. Uranium 92-236. Right? So these are the examples for what here? The isotopes. What are isotopes? The nuclei with same atomic number but different atomic mass number. Those are called as what? Those elements are called as what? The isotopes. Right? Isotopes. Now what are isobars? So you note down these examples of there may be one more question in the examination. What are isotopes? Give an example. Right? They may ask the example for 1 mark, or they may ask what are isotopes for 1 mark, or for 2 mark what are isotopes. Give an example in this way. Right? Now the next point, what are isobars? What are isobars? The nuclei with same mass number but different atomic number are called as what? The isobars. Isobars. What are isobars? The reverse of this, right? Same mass number, that is the atomic mass number, but different atomic number. Those are called as what? The isobars. What are isobars? The nuclei of an element with the same mass number but different atomic number. Those are called as what? The isobars. Here we can give the examples. So 1H 3, right? Hydrogen 1H3. And you know that the atomic number of helium is 2, helium 2. So you are observing here, this is what the atomic mass number, which represents what the atomic mass number, and which represents what atomic number. So here you can see here the same mass number. This is same. You know that generally the nucleus of an element is represented by XZA, which represents atomic number and which represents the atomic mass number. So 1H3, helium 2 3, same mass numbers but different atomic numbers are called as what? The isobars. Right? Now one more point. What are isotones? What are isotones? The nucleus of an element, the nuclei of an element with same number of neutrons. Those are called as what? The isotones. What are isotones here? The nuclei of an element with same number of neutrons. That is called as what? The isotones. The number of neutrons of different elements, right, which consist of what? Same number of neutrons. Nuclei having the same number of neutrons are called as what? The isotones, right? Nuclei having same number of neutrons. Same number of neutrons is called as what? Isotones. So here you can give an example here for isotones with same number of neutrons. Beryllium 49, right? Hydrogen, helium, lithium, beryllium, right? Next element is what? The boron 510. So how you are going to find the number of neutrons here, right? XZA. XZA. So number of neutrons is equal to what? A minus Z. Right? 9 minus 4. It is equal to what? 5. 10 minus 5 is equal to what? 5. Right? The nuclei having the same number of neutrons is called as what? The isotones. So three important definitions were discussed here. What are isotopes? What are isobars? And what are isotones? Isotopes means, right, same atomic number but different mass number. Isobars means what? Different atomic number but same mass number. And isotones means what? The nuclei of different elements having the same number of neutrons. That is called as what? The isotones. So these are the three important definitions we have to discuss here related to the what? The properties of the nucleus. And already we have discussed about the nuclear charge. One more point is what? The nuclear charge. Charge of the nucleus is equal to what? So the charge of the nucleus is plus, but total charge how we are going to represent it. The nucleus consists of what? The protons and neutrons, right? This combinedly called as what? The nucleons. The neutrons are electrically neutral, and whole charge of the nucleus is mainly due to what? The proton. Therefore, what we can write here? The nucleus consists of what? Z number of protons, and charge of the proton is plus E. Then total charge is equal to what? Total charge of the nucleus is equal to plus Z. Plus Z is equal to what? The total charge of the nucleus, because of what? The protons, right? This is regarding the what? The charge of the nucleus. We represent it what? Plus Z, right? This is related to what? The nuclear charge. Now how you are going to represent the nuclear mass? Nuclear mass. So all these points are very important. These are the basic points related to discuss the next points related to the properties of the nucleus, as well as the next concept in the chapter nuclei. Nuclear mass. So how we are going to represent the total mass of the nucleus, right? So total mass of the nucleus, if Mp is the mass of each proton, and Mn is mass of each neutron, right? Nuclear mass we are going to represent here, total mass of the nucleus, right? Mp is mass of the each proton and Mn is mass of each neutron. Then total mass is equal to what? Right? Total mass of the nucleus is equal to what? The sum of masses of the protons and neutrons. Then how we are going to represent the number of protons here? Number of protons is equal to number of protons is represented by the symbol what? Z, total number of protons. And total number of neutrons is equal to what? Total number of neutrons is equal to A minus Z. Then total mass of the nucleus of the nuclear mass is equal to Z into Mp, that is total number of protons into mass of each proton, Z into Mp, plus number of neutrons is equal to what? A minus Z into mass of each neutron. So by using this equation we have to represent here the what? The nuclear mass or the total mass of the nucleus. M is equal to Z Mp plus A minus Z into here it is Mn, right? Z Mp, Mp is mass of each proton and Mn is mass of each neutron. So total mass of the nucleus M is equal to Z Mp plus A minus Z Mp. Z represents total number of protons and A minus Z represents total number of neutrons. The next point related to the properties of the nucleus we have to explain here. The next point regarding the properties of the nucleus, that is equal to the radius of the nucleus, that one also we have to represent here, or the nuclear size in terms of radius we have to represent here. A nuclear size. The next property of the nucleus, that is the nuclear size. So from the Rutherford alpha particle scattering experiment or from the experimental studies shows that the size of the nucleus is finite. The size of the nucleus is finite and the volume of the nucleus is directly proportional to the what? The volume of the nucleus is directly proportional to what? Its radius or its atomic mass number, right? V is directly proportional to what? A. So as the atomic mass number goes on increases, its volume also goes on increases. V is directly proportional to A. But V is equal to what? That is the volume of the sphere what we are going to represent here. 4 by 3 pi r cube. Here r is the radius we are going to represent here. Now therefore 4 by 3 pi r cube but V is equal to 4 by 3 pi r cube. Now from these two equations what we can write here? 4 by 3 pi r cube is directly proportional to volume is directly proportional to what? The atomic mass number, right? So radius of the nucleus, from this equation what we are getting the relation here? The relation between the radius of the nucleus and the atomic mass number. Now just by raising the power 1 by 3 on both sides, let us find here how that radius is proportional to A. Raising the power 1 by 3, what we can write here? R is directly proportional to A to the power 1 by 3. So here this 4 by 3 pi is a constant. Again we get one more proportionality constant here. That proportionality constant is equal to what? R is equal to R0 into A to the power 1 by 3. So there will be one more question, how the radius of the nucleus is related to the atomic mass number. That is what? R is directly proportional to A to the power 1 by 3. Here R0 is the proportionality constant. Here R0 is proportionality constant and its value is equal to 1.2 into, its value is equal to 1.2 Fermi or 1.2 into 10 to the power minus 15 meter. So 10 to the power minus 15 meter is equal to what? Fermi. Therefore, the value of R0 is equal to what? 1.2 Fermi. So in this way we are going to represent here the nuclear size. The nuclear size, that means what? The volume, it is obtained from the experimental results here. The volume of the nucleus is directly proportional to the what? The atomic mass. But we know that V is equal to what? 4 by 3 pi r cube. That is the volume of the sphere, 4 by 3 pi r cube. Then 4 by 3 pi r cube is proportional to A, right? 4 by 3 pi r cube is proportional to A. So the 4 by 3 pi is a constant term, right? Now raising the power 1 by 3 on both sides, R is directly proportional to A to the power 1 by 3. So here with this constant, one more proportionality constant R naught, we are getting the total value is equal to what? The proportionality constant value is equal to what? R naught is equal to 1.2 into 10 to the power minus 15 meter. Or it is 10 to the power minus 15, 10 to the power minus 15 meter means it is a Fermi, right? Therefore R naught value is 1.2 Fermi. So how the radius of the nucleus is related to the atomic mass number, you have to give the answer as what? R is directly proportional to A to the power 1 by 3. The next property related to the what? The properties of the nucleus, we are going to write here about the nuclear density. So nuclear density it is equal to what? You know that density is equal to the what? The ratio of mass divided by 1, right? But here nuclear density means what? What we have to take here? Nuclear mass divided by nuclear volume, right? Nuclear mass divided by volume of the nucleus. So density is equal to mass divided by volume. Therefore, the nuclear density is equal to nuclear mass divided by volume of the nucleus. So how we are going to represent the nuclear mass here, right? So let us represent the density as a rho. Therefore, rho is equal to nuclear mass, that is M, nuclear mass, and volume of the nucleus is equal to V. But M is equal to what? Nuclear mass is equal to Z into Mp plus A minus Z into M, and the volume of the nucleus, it is represented as what? 4 by 3 pi r cube. This right here, separately let us calculate here. Volume V is equal to what? 4 by 3 pi r. But we know that what? R is equal to what? R naught into 8 to the power 1 by 3. Therefore, V is equal to 4 by 3 pi r cube, but R is equal to R naught into 8 to the power 1 by 3, or naught into 8 to the power 1 by 3. So V is equal to 4 by 3 pi R naught, right? So R naught into we are going to represent here 4 by 3 pi. So it is R naught into 8 to the power 1 by 3 whole raised to 3, right? R naught into 8 to the power 1 by 3 in place of R, I have done R naught into 8 to the power 1 by 3 whole raised to cube here, right? So next R naught cube, it is 8 to the power 1 by 3 whole raised to 3. So 3 get cancelled here, A is remaining. So now I have got the volume as 4 by 3 pi R naught cube into A, right? 4 by 3 pi R naught cube into. Now, as from this table you know that the mass of the proton is nearly equal to the mass of the neutron. If we consider Mp is nearly equal to Mn, so this what we can write here, right? This total mass becomes what? A into mass of the proton. So it is the total nucleons we have to consider and the mass of each proton or neutron you have to consider, right? Because of both having the nearly equal mass, just by replacing, just by what? Taking the whole mass as what? A into Mp. That is the total number of protons and neutrons is A. You have to consider here mass of the proton or neutron. Therefore, rho is equal to what? I will write here A into Mp divided by 4 by 4 by 3 pi r naught cube into A. So this A and A get cancelled here. So density is equal to what we are getting? MP. So this 3 goes to numerator. So 3 MP divided by 4 pi r naught cube. So density finally what we are getting here, rho is equal to 3 into MP divided by 4 pi r naught cube. So all terms involved in this equation are constants. Mass of the proton is constant, 3 is constant, thus 4 is constant, pi is constant and r naught is constant. So with this what we can give the conclusion for the property, that is the nuclear density. So the nuclear density is independent on what? It is independent of mass number. There will be one mark question. How the nuclear density is depends on its mass number. It is independent, right? Nuclear density is independent on mass number, that is right. That means what? All the nuclei have approximately the same density. All the nuclei have approximately the same density, because the rho density of the nuclear density we are getting the equation as 3 mp divided by 4 pi r naught cube. All the terms involved in this equation are constant. So the nuclear density is independent on the mass number 3. Therefore, all the nuclei of different elements having the same nuclear density. So rho is independent on A. This rho doesn't depend on what? So these are the important properties related to what? The nucleus, right? What are the constituents of nucleus? That is nucleons, protons and neutrons. How we are going to represent the composition of the nucleus, how to find the number of protons, how to find the number of neutrons, right? What are isotopes, what are isotones, what are isobars, what is the charge of proton, what is the charge of the electron, neutron is electrically neutral, right? What is the nuclear mass, what is the nuclear density. So all these are the important introduction point of this chapter nuclei. Right, in the next video class, we're going to discuss about the next points related to the chapter nuclei. Thank you, students.